Good afternoon. Welcome to Mathematics in the PM. This is the Digits and Diamonds coming at you live and recorded. Okay, we're taking it up where we left off 2 days ago. Scale diagrams and enlargements. We did a review of metric conversions because we need to be able to switch back and forth between centimeters, meters, and millimeters. And it's useful to know how to go to kilometers, etc., other things too, but our problems will just stick to centimeters, meters, and millimeters, okay? If you know another way, go ahead. But this method that I'm showing you is actually gonna help us out in some other ways within this unit. That's why I'm showing you this method. You just know how to switch by just counting decimal places, go ahead and do that when it comes to centimeters. We talked about, and I had to use your textbook because your photocopy didn't come out correct, matching sides, corresponding sides, called it. And then we took a ratio. This smaller figure is half the size of this, or the other way of saying it is this is twice as big as the other one. And I am frozen, thank you. You don't know what I'm talking about. Okay, so we left off with this. We used our rulers and measured in millimeters. We got to know how to use rulers. You come in. And we found that all of the ratios of the sides are the exact same. They come out to a ratio of 2. We didn't even need decimals. Then we reviewed some facts and vocabulary. And I'm just going to freeze the screen while I update accounts quickly. A few things though, guys, where we left off. When we do a scale factor, like that fraction system, we want the diagram measurement on the top, the actual measurement on the bottom, okay? The actual size of an object, okay? There's a bunch of things here that we'll refer to again and again here. We went over them, but I think we intuitively understand the idea of an enlargement, larger picture, and a reduction is a smaller picture. We'll stick with that right now. We might have to refer to some of those things if you need to. Okay, we're going to pick it up here on the fourth page of your handouts. Determine the scale factor that was used to transform the diagram X, so that's the actual picture, into Y. And that's the new one, as a fraction and as a decimal, okay? So you're going to have some problems like these, so let's do an example right now. And I'm going to follow my screen because I'm talking. There we are. Okay, talking about something you couldn't see. We're all with me now? Yeah. If you remember, I'm going to flip back the screen again to remind you, though. We sometimes use the letter K. I don't care about that. But the diagram measurement needs to be on the top. The actual, the original measurement needs to be on the bottom of your fraction. Don't lock yourself up, or don't lock the next person up. Okay, back to this now. So, we're going to call it the letter K. We're going to say, well, inside of K is equal to, I use a handwritten. That's a handwritten. Anyways, determine the scale factor. From X, that's the original, so that's the bottom, into the diagram Y. Now, if I look, I'm going to go with the width, the short side. There's 1, 2, 3, 4, 5, 6, 7, 8 on here, right? If I count this, cross. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to put 8 squares on the bottom is matched to 12. You notice how I use the same type of matching sides? Now, as a fraction, remember how to reduce that one? We can divide the biggest number that you can divide into both. 12. to divide the top by 4, I'm going to divide the bottom by 4. I could say K is equal to, divided by 4 is 3, 2. So my scale factor is a fraction. I put it in lowest terms. Or as a decimal. If I use my calculator, or if you think of this one in your head, 3 divided by 2. Every fraction can be considered a division problem if you want a decimal. 1.5. Okay? That's the other answer. Be able to come up with either one. Yes? Every fraction can be considered a division. So I go 3, top number divided by bottom. It even would have worked with 12 divided by 8. Okay? But what this means is, and sometimes you can see it better with the decimal number, is that the diagram Y is 1.5 times bigger than the original. Does that make sense to you? It's not twice as big, but it's 1.5 times bigger. Okay. Okay. Any other questions about that? So if you see 2 diagrams, determine the scale factor. You might be saying, well, what if I did it on the long side? I'm going to pretend maybe you were thinking this through and thinking, what if I did this? If I count this on the X, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. I'm just redoing this. It should be the same answer. And if I took the Y long side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. And I've divided 12 and 18 by the biggest number I can think of, 6. Divided both by 6. I should get 3 out of 2, which is the exact same answer. So it didn't matter which one you chose. What I did in blue is the exact same final answer as the red. Just showing you. If something's truly drawn to scale, it doesn't matter as long as they're matching sides. All of the sides would come up with the same scale. So you don't normally have to do it twice. I'm just showing you why. It all comes up. Alex, you have this from the other day. Is that what you have? Awesome. Okay. If you're just joining in for our video, this is Mathematics 9 in the PM. I'm your host, Joel Shindell. Okay. Now for a commercial. Oh, we want. Well, when you hear it. I'm going to do one of my shoutouts, or Ron's shout. Let's go. Determine the scale factor used in each situation, but this is without a diagram. Each measurement must be using the same units. Oh, this is like meters and centimeters. The actual length of a billboard, so actual is on the bottom of the fraction, is 4.5 meters. In a scale diagram, though, it's 50 centimeters, because I'm trying to draw it on paper. 50 centimeters is actually quite large, too, so it's a big sheet of paper. We need to have the same system. One's in centimeters, one's in meters. Choose one system and stick with it. Do we want to keep centimeters or do we want to keep meters? Okay, we'll keep centimeters. And it didn't matter which one you chose. I'm going to change 4.5 meters to centimeters so that we have both in that same system. So first, convert. This is what I'm doing. Convert to centimeters. I'm going to set it up the way we did before. You can flip to the first page. You can ask me, but I'm going to, you ask me, and here's what I'm going to say. How many cents in a dollar? And you would say, what? 100 cents in a dollar. And then, or I might ask you, how many years in a century? And you'd say century, 100 years. Okay, so how many centimeters in a meter? Cent, 100. Okay. So I'm going to say 100 centimeters to 1 meter. Now I'm going to create the fraction on the other side and match centimeters on the top, meters on the bottom. The actual length of a billboard is 4.5 meters, so I'm going to put that 4.5 here. So there's meters on the bottom on both sides. Then X on the top. I make my fancy X. And do you guys remember ways of pays? How do you solve this equation? Cross multiply, divide by the log. Dividing by 1 is easy. See, later on you'll have some that don't have 1s. So 100 times 4.5, which you might be able to do in your head. It's 450, then divide by 1. So X equals 450 centimeters. So really, what I just figured out is I could replace this in the sentence here. The actual length of a billboard is 450 centimeters. And yes, you could do that in your head without showing any work. I'm fine with that. If you can do that consistently and get it right, go ahead. Now, the scale factor, though, I still haven't figured that out. Okay, we're going to use the letter K. You can make yours a handwritten K. You can make yours a printed K. I use a small K. So the actual one is the 450. And the diagram one is 50. You notice that we have matching units? You know what happens? And you guys are kind of new to algebra a little bit. You might have seen some stuff like this in grade 8. If I have a CM on the top and I have a CM on the bottom, what do you think? You guys have any memory of what can happen to those when they're the same thing over the same thing? Nobody? Trust me on this because you'll get used to this. As long as they're both centimeters, I can just cross those off. It's like a 1. So 1 centimeter divided by a group of centimeters. But the numbers still have to come up. You know what? I didn't say that the scale factor had to be a decimal or a fraction. Since we have calculators, I think decimals are easier though, right? And Jackson, you remember this because you asked me about it. I'm hoping you do. So check it. How do I change that into a decimal? Yeah, top number, 50. Oh, I got to turn this on. But yeah, 50 divided by 4. I get the decimal. 0.111111. Well, okay, let's not get ridiculous. I'm going to just. I'm going to just put 3 of them. Don't just put 0.1. Include a few others. 2 or 3 decimal places in this case. It goes on. If you wanted to use a bar short repeats, you can. I'm fine with use proper rounding, cutting off in a few spots. Questions for me? I have more questions for you. Okay. That means that this one is smaller. And you can tell right from there. The billboard is huge. 450 centimeters, 4.5 meters. You guys know how big a meter stick is, right? And then on the drawing is how big is 4.5? 1, 2, 3, 4. It's basically these two boards. That's how big. When you think about a billboard that's up above the Luban, you know, I'm driving by, so it's pretty big, yeah. That's why if you're going to draw it on paper, the decimal 1,1, it's like 11% the size of the real image. That's what that tells you. Smaller. Okay, the actual size of a stamp is 36 millimeters, but in a scale diagram, you drew a huge 2.4 meters. Some kind of huge poster. Son of a gun. We've got 2 different systems now. What do we want to go to? Everything in millimeters or everything in meters? It doesn't matter. You guys choose one. I'm going to ask someone to this side. Choose it. Millimeters or meters? Okay, I heard millimeters and I heard meters. Meters, okay. I heard meters more than millimeters. it doesn't matter. So I'm going to go for 36 millimeters, 2 meters. Oh gosh, millimeters. What are those? How many millimeters in a meter? I do know. 1,000, yeah. So I'm going to put 1,000 millimeters. I'm going to make my fraction for 1 meter. That's how many little tick marks are on this meter stick, right? And the actual length of the stamp is 36 millimeters. So I'm matching that top, millimeter. X. 36 times 1, that's still 36. Divide by the lower. Cross multiply the diagonals. Divide by 1. 36 divided by 1,000. Good golly. You know what this is? Some people can do it in their head. If not, use a calculator. I'm going to write it down, but I'm waiting for you guys. I'm doing it in my head. What is it? You guys figure it out. 036. You did that in your head, didn't you? You read it off. Oh, okay. Okay, I don't care. I thought you actually. You can divide by 1,000. Anything with just like 10, 100,000 stuff. It's just moving the decimal. That means I won't care. Use a calculator if you don't. Still haven't got a scale factor, but now we can do it. Scale. I'm labeling my work so that your teacher can follow it really well. And my scale factor as a fraction is going to be the actual, so that's the bottom, meters, matched to 2.4 meters. Quite a large poster. There's the fraction. But we know we got to divide it. So I'm going to put that in there. 2.4 divided by 0.036. 66.7. Because it's 6 is repeating forever. But I've got 3 digits now, so. That means that the poster of the stamp is 67 times bigger, 66.7 times bigger than the original little stamp. But you know the stamp's a little bigger than your thumb, right? That's the scale factor tells you, okay? Oh, God. 2 classes and you still haven't done any work. Yeah, don't worry. I'll let you pause for a second. Did I start the recording? Get ready. We'll knock your socks off. Last page. It's from the textbook. I didn't draw that. I scanned it. I didn't draw it. No, I didn't actually do it. The textbook did. Example. The drawing of a mosquito was printed in a newspaper article about West Nile virus. The actual length of the mosquito is 12 millimeters. Determine the scale factor of the diagram. Well, once again, since they're using millimeters, you guys need rulers. Now I have a picture of a ruler. You're not going to use it. You're going to actually use them. Oh, so it's fun, right? But that got cut off this. Well, but you can go from tail to tail. Or tail to tail. You should be able to hear. Who needs these? You need a couple? No, you don't? Do you? Because we got to get using millimeters, and I'll measure with you guys, but my ruler, because it's online, won't be the same. Yeah. Please don't get returned. All through your tool. Good one. Well, Okay. Because your photocopy thing got screwy again. Now, yours is not, my measurement isn't going to be right. But essentially, take the top. And you see this, your zero is lined up with this end, right? I'm messy there to this end. Now, mine is 4.5, but that's not necessarily what you guys have. What do you guys have as a distance? 5 what? Is that centimeters? What is that in millimeters of? 50 or 500? I heard both. All right, because 500. Yeah, we won't even talk. Okay, so you guys are telling me that that is 50 millimeters. Is that right? Okay. We've used the same measurement units. We know how to use millimeters on one of these. Okay. So the actual over the, or I said it upside down. The drawing, 50 millimeters, over the actual, which was 12 millimeters. Okay. Handwritten K. Old people like me handwrite. Okay. I guess I need to use, now that is a good fraction, and you could actually reduce it a bit. 25 over 6. But let's go with the decimal thing. 50 divided by 12. Oh, I gotta turn mine on. 50 divided by 12. I get 4.17. I'm going to use round. There's 3 digits in it. That means it's a little more than 4 times bigger, that picture on your page. 4 times bigger than the actual mosquito. Okay. Need to know how to use rulers, and I'm pretty sure I have some textbook questions with rulers needed, so you can keep that. Yeah, you do, eh? Okay. Well, you got the thing in textbook stuff. Now, today, I'm insisting that you all use your textbook, because I need to know who's missing their textbook. Everybody only use the textbook that you were assigned. Don't just double check the number, but open it up inside the book you printed your name. Okay? But there you go. I'm going to stop the video too. Everybody's good with this? I'm going to freeze the screen.